Hello, my dear friends and followers. This is Abhishek. I welcome you to my channel Ayodhya Informative. In this video, I will be starting with first chapter of 10th, that is Arithmetic Progression. So before going to start with this chapter, if you are watching my videos for the first time, I request uh, to subscribe to my channel, like, share and comment. So let's get started. So in this video, I will be giving introduction to arithmetic progression, and also I will be giving a definition what is arithmetic progression, and some of the examples and all. And in the next video, I will be solving exercise 1.1. So before going to exact definition of arithmetic progression, I will give you some examples, real life examples, so that it will be very easy to understand what exact meaning of arithmetic progression. So in our day-to-day life, we have seen many objects and many things. For example, we have seen a ladder. So ladder means it has some rungs and all. So that rungs are arranged in some patterns like this. So if this is a ladder, these are the rungs. So these rungs are arranged in some patterns. How means the difference or the gap between two consecutive rungs should be same in the ladder. So like this, we have seen many of things in our day-to-day life. So like this, an arithmetic progression is also arranged in some pattern. How? Let's see. First of all, the arithmetic. What is arithmetic means? Arithmetic is a branch of mathematics which deals with the operations and like subtraction, addition, multiplication, division, and also it deals with the numbers. Everything is deals with the arithmetic. And progression means it is a sequence or it is a series in which a number or in which operations can be done. It is a series. Like, let's see one example for progression. So one. So if this is a progression means it is a series of numbers. It is a series of numbers which are arranged in a particular pattern. How? See here. 1, 2. 1 is the first term. In this sequence, 1 is the first term, first number. To first number, we are going to add another one. It will give you a second number. Like this we get a one sequence. So here we are writing the numbers and some of the operations like addition. We are going to add one to a next term to get a one sequence. Since it consists of numbers and operations, it is an arithmetic, and progression means a sequence. So this is the arithmetic progression. So now let's see what the exact definition and what exact meaning of arithmetic progression. So an arithmetic progression is the sequence of numbers. It is a sequence of numbers in which, so it is a sequence of numbers. So arithmetic progression is a sequence of numbers in which each term, what is a term? In a sequence, each number, every number is said to be a term. In a sequence, if it is a sequence, 2 is one term, so it is one term, it is another term, and it is one term, it is another term, it is another term. Like this, in a sequence, each number is said to be a term. So, an arithmetic progression is a sequence of numbers in which each term is obtained by adding fixed term. Obtained by adding a fixed term. Here, fixed term or fixed number means, see here in this sequence, except first term, 4 is getting by adding 2 to the preceding term. Means the difference between two consecutive numbers should be same. In simple words, an arithmetic progression is a sequence of numbers in which a difference between two consecutive numbers should be same. Means if we subtract a by first term, second term by first term, second term by first term, that should be same. Means how? 4 minus 2, 4 minus 2, 2. 6 minus 4, that is also 2. 8 minus 6, 2. 10 minus 8, 2. So if we subtract the two consecutive numbers, then after what value we are getting after subtraction, that should be same in whole sequence. That even in that case only we say that it is an arithmetic progression. So now let's say another example: 3, 6, 9, and then 11, not 11, yeah, 11 and then 12. So in this example, we can see the difference between these two consecutive is 6 minus 3 is 3, 9 minus 6 is also 3. These three are same. So 11 minus 9 is how much? 2. Here it is 2, here it is 1. So here in this sequence, the difference between the two consecutive numbers are not same. And means we are not getting a sequence by adding a fixed number. Hence it is not an arithmetic progression, isn't it? So an arithmetic progression is a sequence of numbers in which each term is obtained by adding a fixed number to the preceding backward number to the preceding number. If we are adding a fixed number to the preceding number, then we are going to get one sequence. That sequence is known as arithmetic progression. So here there are some terms like, let's say, if a sequence, that means let's 1, 2, 3, 4. So it is an arithmetic progression. Why? Because here it is a sequence in which each term is obtained by adding 1 to the preceding number. How means 1 to 1, if we add 1 we get 2. For 2, if we add 1 again 1 we get 3. To the 3, if we add 1 again we get 4. Like this we are adding 1 to every term in this sequence. Hence it is an arithmetic progression. So here another definition comes, that is, in a sequence, if there are infinite numbers, or in a sequence if there are infinite sequence, then that sequence is known as infinite sequence. Infinite sequence. Now in a sequence, if mm, in a sequence if there are finite number of terms, Finite means it can be counted. If in a sequence, if there are countable number of terms are present, then that sequence is known as finite sequence or finite series. Hope this is clear for everyone. If any doubt in this particular definition and examples, let me know through a comment section. Now let's see how we can write an arithmetic progression in general form. Means here if we take A as the first term of an arithmetic progression or an arithmetic sequence, then D is the common difference. Means if we consider a sequence like this, here 1 is the first term, it is denoted by A. Here 1 is the first term of this sequence and it is denoted by A. And 2 is the second term. How we can obtain A plus D? But we don't know D here. How? Means we can take the difference between these two numbers or these two numbers or these two numbers. Means the common difference, the difference between two consecutive numbers should be same, then only a sequence is said to be an arithmetic progression. If we see here, the difference between these two numbers is 1, 3 minus 2 is 1, 4 minus 3 is 1. Then here every term, every proceeding term is obtained by adding 1 to the next term. Hence, 1 is the common difference. It is denoted by D. And similarly, we can obtain third term, fourth term, and so on. And also we can write A1, A2, so on up to AN. AN means nth term, last term of the sequence is denoted by n. Here it is the general form of arithmetic progression or arithmetic series. Here A is the first term of the sequence as I have said earlier. D is the common difference, means difference between these two terms, first and second, second and third. Third and fourth term is said to be as common difference. So for better understanding, I have taken one example in general form. So let's take first term A, first term A as 1 and D, common difference D as 2. Here A is 1 and the common difference D is 2. So here A is 1 and here A plus 2 is common difference D. So see here, see A plus D, A plus D. Now here 1 is A plus 2, 2. What is common difference here? 2. It is D. A plus 3 is here 3 into 2 is common difference D. Now from this term we can get an AP, arithmetic progression, or a sequence in arithmetic progression. 1 plus 2 is 3, 2 2s are 4, 4 plus 1 is 5, 3 2s are 6, 6 plus 1 is 7, and like this so on. Now let's see 1, 3, 5, 7. We get one sequence over here. Now how to check whether this sequence is an arithmetic progression or not? Let's see. Let's take the difference between the two terms. These two terms. So the difference between consecutive number should be same. If you take a difference between any two consecutive means one after the other, one after the other, one after the other. That is consecutive. If you take a difference between 1 and 5, that is not a consecutive number. So if you take a difference between consecutive numbers, any two consecutive numbers, then after subtracting or and after taking a difference, the what value we get through the sequence, that should be same. How? 3 minus 1 is 1, that is 2, sorry. 5 minus 3, 2. 7 minus 5, 2. See here, second term, if we let's call first term as a1, second term as a2, third term as a3, fourth term as a5, sorry, a4, so on, or else a0, a1, like that. Whichever convenient you can take, that is a0, a1, a2, so on up to an. N is last term of the sequence. Now here a0 is 1, a1 is 3, a2 is 5, a3 is 7. Here difference is a1 minus a0 is d, and a2 minus a1 is d. That is common difference. If we take a difference, or if we subtract a1 minus a0, or second term minus the first term, that should be a common difference. So see here, as earlier we have assumed common difference as 2. After getting a sequence, we also get a common difference as 2. Hence, the given sequence, or the 1, 3, 5, 7, this sequence is said to be an arithmetic progression. Why? The difference between two consecutive number is same, or the every term in this sequence is getting after adding a 2 to each term. Hence it is known as arithmetic progression. Let's solve one or two examples over here. Now let's consider one sequence. So it is an arithmetic progression. So why 2? It is the first term. To the first term, if we add a 2, we get 4. To the 4, if we add a 2, again we get 6. To the 6, again we have to add a 2. Then the common difference is same between every term. It is the same, hence it is known as arithmetic progression. Now here 2 is a. So first term is denoted, or first term of arithmetic progression is denoted by a. That is, in our example, a is 2. Now the common difference, how we can calculate a common difference? That is common difference. Common difference is denoted as d, which is equal to a2 minus a1. Here it is a2, a1, a3, a4, a5. These are the 5 terms. A2 minus a1, that is 4 minus 2, which will be 2, and 6 minus 4, which will be also 2, and 8 minus 6 is 2, 10 minus 8 is also 2. It is the common difference. Therefore, the d common difference is 2. Hence, it is an arithmetic progression. These are the 1 mark questions that may be asked in the examination. So I will solve some more examples, most probably in the next video. And let's solve one example like um, so in the examination, it might be a possible for as asking like that they might given you a first term A as like 2, and also they have given you a common difference B as, let's say, 3. So using these information or using these data, they are asking you to form a sequence or form an arithmetic progression. How we can form an arithmetic progression using these two data? Let's say, as I have said, as I have explained earlier about the general form of an arithmetic progression, using that we have created one arithmetic progression. Let's say here, general form of an AP is A is the first term, then A plus D, A plus 2D, and also it might be given like, sorry, A plus 3D, so on. Now, the here we should substitute these information here. A is first term, also given in the question only. 2 A plus D. 2 plus B is 3, and A plus 2B. 2 into B is 3. Sorry, A here is 2. Then next A is 2 and 3 into D is 3, like this. First term is 2. 2 plus 3, 5. 2 3s are 6. 6 plus 2, 8. 2 plus 3 3s are 9. 9 plus 2 is 11. So let's check whether it is a required sequence. Let's check whether this is an arithmetic progression or not. How to check? Also, we can cross verify whether this is correct or not. Means, let's take a difference between a consecutive number. 5 minus 2. What is 5 minus 2? 3. 8 minus 5, it is also 3. 11 minus 3, sorry, 8, it is also 3. So here the difference between two consecutive number, any two consecutive number is 3, 3 in everywhere of this sequence, and it is also matched or common difference. This is D. This common difference 3 is also matched with the given D. Hence, it is an arithmetic progression. So, there are some more examples and some questions, and they might be asked for general terms. Everything is asked in might everything should be asked in the examination. So it's all about today's video. Let's continue with the next video. In the next video, I'm going to start with exercise 1.1. In that, I will solve everything given in the exercise 1.1. Along with that, I'm sharing a notes, handwritten notes in that video. and I will solve some more example for the perfection. If you are like this video, then share with your friends. They might get also help from this video. And don't forget to subscribe. And thank you.